All right, well, let's go ahead and get started here. All right, so welcome to the Kubernetes Fortnight. We do these every 2 weeks. Once in a while, maybe we miss a week and come in like a week later, but this one is on Appctl and in Keynative. You go to the next slide. We've got Sirish, which let me go ahead and let me hand it off to Sirish, and Sirish can introduce everybody, and we can go ahead and start presenting on the information, or do you want me to introduce everyone?
Absolutely. Mike, thank you for having the Appctl team today. It's a pleasure to be here. Folks, thank you for tuning in today. My name is Sirish Raghuram. I'm one of the founders of the company at Platform 9. I'm also the Chief Growth Officer, a fancy title where it's grandiose and self-important. I'm delighted to have with me today two of our senior most engineering leaders. Nikhil is our Director of Engineering and leads a lot of our growth engineering efforts. And Anup is our Senior Staff Engineer who, Nikhil and Anup have been two of the creators of Appctl. And it's a pleasure to have them today to talk about why we created Appctl, what the motivation was, and our vision for where we want to take Appctl. Okay, Mike, thank you for having this session. It's exciting to be here. Let's go to the next slide. So in the agenda today, we'll talk a little bit about why do something? Why was Appctl created? What is it? And how does it work? Appctl uses, it's a Kubernetes native technology. It runs on Kubernetes and Keynative, and we'll talk about that a little bit. And we'll actually do a demo. So that should be fun. So I look forward to the session. Next slide. Let's start with why. I'm a big fan of Simon Sinek and starting with why. And the motivation behind Appctl is that after all these years, it's now been what, 9 years, 8 years since Docker first kind of came out. One of the things that I remember about Docker is when it first came out is how delightfully simple and easy it was to use. You could just do Docker run and you could run an app, right? It was beautiful. And, so much time has passed and, the world has grown and the container orchestration platforms and Kubernetes has grown and matured and is so powerful today. But all that power comes with a big downside, and that downside is the complexity. So if you think about most application engineers are out there, application development engineers are out there, what they really want to focus on is their applications, right? And if you think about their experience that they get from any Kubernetes environment today, deploying and operating applications on Kubernetes is extremely complex. And it forces developers, even if they don't want to deal with a lot of low-level infrastructure constructs and plumbing. And this in turn, it's a distraction from what they really want to focus on, which is the core business logic. But B, it is oftentimes there's a skill or a time challenge, and it creates a reliance on infrastructure and operations teams. So now, the developers now need to work with, they need help from infrastructure and operations teams, who, by the way, are constantly busy, and they're getting pounded. Show me one infrastructure operations engineer who doesn't feel like they're spread too thin and getting overwhelmed with all the conflicting requests that come to them, right? And so in order to provision and run apps, they need to provision and run nodes, create Kubernetes clusters, then deploy the app and expose the app in the right way with the right kind of access levels and privileges and security configurations and so forth. And this is really the motivation for where Appctl's journey began is, 8 years ago, it used to be delightfully simple to be able to run applications on Docker. And why have we lost that simplicity with Kubernetes? How do we make deploying and operating apps delightfully simple for developers while staying true to Kubernetes and while not trying to hide Kubernetes, but taking advantage of the power that Kubernetes has? How do we delight developers and shift cloud native left? So developers are, shift left is this standard industry nomenclature for enabling developers to do more. And one of the things we are inspired by is the Git workflow. If you think about Git, there were source code systems before Git came about, but Git made subtle changes to the way branching works, where it gave developers so much more control in terms of being able to branch your source code repository, publish it, make changes, and run from it. And now everybody's familiar with Git and how to operate on a Git-like system. And we want to bring the inspiration behind Appctl is, wouldn't it be nice if just as easily as developers can, clone a branch in Git, make changes, commit a change, and then can they also run an app at every change level? Can we make it so easy, as easy as the Git workflow, right? That is some of the motivation, the why of how Appctl came to be. Let me actually use this as an opportunity to bring Nikhil and Anup, who are the creators of Appctl, into the conversation. So Nikhil, let me turn the ball over to you to talk more about the problem and compare and contrast and take it from there.
Sure. Thanks, Sirish. Hi, folks. I'm Nikhil, working with growth engineering team at Platform 9. So yeah, as the problem is very subtly explained by Sirish, let's now move on to the solution that we have, and the Appctl is the solution that we just launched during last week of December. So if you just could look at the scenario before Appctl, for example, a developer has to deploy an app on a Kubernetes cluster. So firstly, she has to provision a number of nodes, then create a Kubernetes cluster with some configuration, and then create a app deployment YAML with various number of parameters, including replicas, port information, the resource request, etc. Finally, after deploying the app, the developer has to create a service to access the app, and then also deploy something like ingress controller or a cloud load balancer, so that the app is finally accessible. And then after app is running up and running, then the work doesn't stop there. We have to monitor in general replicas, resource parameters, and app performance, and then it just goes on like that. This typically takes days and weeks to get the app going on a Kubernetes cluster. But with Appctl, it's been just reduced down to 3 steps. We just now have to download Appctl. We have to log in to Appctl using GitHub or Google SSO login. And then finally, we just have to fire Appctl deploy command with the container registry path for the application. So the app gets running in just a few minutes. That's the beauty of Appctl. So we have tried to provide as less number of commands for Appctl. Again, to provide simplicity, as Sirish had mentioned. The first command is Appctl login, just to log into Appctl with Google or GitHub SSO. Then the most important command is to deploy the app using Appctl deploy. Then we can see all the listed, all the deployed apps using Appctl list. If you want to get any detailed information about a deployed app, then we need to execute command Appctl describe. And last but not the least, the Appctl delete command to delete a specified app. Appctl benefits. So number of them, and you might have realized by now, very easy deployment of apps is possible due to Appctl. It also helps in unified developer experience. Each app is basically deployed as a container image, which is a pretty standardized way of deploying app. Very importantly, no prior Kubernetes experience is needed, as Sirish had mentioned. Kubernetes is very powerful, at the same time very complex. So you need to invest good amount of cycles to learn Kubernetes. So this just gets rid of those efforts. It also makes possible serverless management, taking automatic care of scaling, descaling, depending on the load on the app. Then it also has a provision to scale to 0, meaning if there is no request, then the number of application pods, they scale down to 0, thereby helping in cost optimization. Finally, Appctl has support for any programming language because it just it's a containerized way of running application. So basically underlying operating system and everything remains the same. Just we are trying to compare the PMK, that is the flagship product of Platform 9, which is Platform 9 managed Kubernetes, and Appctl over here. The PMK is very popular product out there. It provides a SaaS control plane to deploy, monitor, maintain, upgrade, and support Kubernetes clusters. It gives complete control over various aspects of deployment like networking, observability, storage, etc. It also provides a unified management plane for various Kubernetes clusters in different environments, different ecosystems like on-premise or various public cloud ecosystems. On the other hand, Appctl gives us complete freedom from deployment activities, and it also lets developers focus on creating apps without bothering about the deployment details. It also provides scalable serverless execution. So let's dwell down into the architecture of Appctl. So the user firstly creates a image. It's mentioned over here as Docker image, but can be any container runtime image from the application source code. After the image is built and put into any container registry, user can just log into Appctl and execute command appctl deploy, which from here goes to the Platform 9 environment. We have a microservice running called as application controller, which gets the command from any user running Appctl CLI. It then invokes Keynative APIs on a PMK cluster, the Platform 9 managed Kubernetes cluster, which is running on AWS environment. So then Keynative, whenever gets a deploy command, it actually creates the app endpoint so as to facilitate accessibility of app. So interestingly, it doesn't create any pods at this point in time. It just creates the app endpoint and then sends it over to app controller, the application controller, which in turn sends it over to the user. And when user tries to access the app endpoint, at that point in time, application pod is created. So as we saw, the scale to 0 approach is same. If there is no request, the number of application pods, they go down to 0. And whenever there is a request hitting the application, we have a, just a second, we have a application pods running over here. So this is a very high level architectural overview of Appctl. Let's now try to understand the current state of Appctl. We released this particular utility during last week of December, and this is still in alpha. But still, this has a lot of useful features made available. The app can be deployed from a public container registry right now, any public container registry. Right now, the endpoint supported is HTTP. There is also a provision to configure port on which the app can run. And there is also support for various environment variables to make the apps configurable. For example, if the app has to talk to some other app, the application endpoints can be made available using the environment variables, and then the app can just pick it up from the environment variables. It also has a support for Google and GitHub SSO login. And finally, it can run on any of the operating systems like Mac, Linux, and Windows. The roadmap for Appctl is quite interesting. In this all in very near term, we are planning to provide support for private registries. We are also planning to have a provision for secured endpoints, that is HTTPS. We are also planning to implement multiple revision support, meaning if a new version of app is deployed, then the Appctl will automatically identify that it's a new version of the same app, and then it will divert all the traffic to the new revision. It will just destroy the pods for the older revision. At the same time, there will be support for traffic splitting. For example, you will be able to configure what percentage of traffic goes to the older revision, and what percentage of traffic goes to the newer revision. And if we specify that, then the Appctl will automatically decide which traffic goes to which revision and automatically adjust it. And finally, we are also working on open sourcing Appctl. We give very high importance for open sourcing activities because we want the community to be benefited because of it. And we believe very soon we should be able to open source the Appctl CLI as well as the backend application controller microservice. So with this, I'll just hand it over to my colleague Anup to provide overview of Keynative and show us the demo of Appctl.
We have a question from Tori. Is this related to Google Cloud's tool called Appctl? If not, how does it differ? It's not the exact same, but it's actually different. Obviously, it's a different product than the Google Appctl. But maybe I'll let Nikhil or Anup explain.
So it's somewhat similar to Google Cloud Run, not Appctl. In that it just lets you deploy the apps directly from container registry. So Anup, do you want to add anything to it?
Yeah, along with that, I think the vision for Appctl is to give flexibility for the users to also pick up the backend of choice. So right now we are doing this in the backend where the services and the cluster is in AWS. It might so happen that we might simply pick up some other public cloud as well, or some private cloud too. So I think the Appctl that is being talked about in the question is only specific to the Google Cloud.
Thanks, Anup.
Thank you.
And I'll just hand it over to you.
Yeah, so let me quickly share my screen.
Yeah.
And yeah, thanks, Nikhil. I'm Anup and I work in the growth engineering team. I'm going to briefly talk about Keynative since Appctl is built on top of it. So quickly building on what Sirish and Nikhil explained, we know that cloud native technologies, the backend architectures have gone the microservices way. The old monoliths have been split up into multiple independent microservices. So if you are an application developer, the focus is on the application and not on the underlying infrastructure. This is especially important since developer wants to focus on the core business logic. So the infrastructure in itself has evolved from bare metal to VMs to containers, and then we also are hearing about serverless functions. Thus, we are moving further and further away from the actual hardware and moving towards abstraction. So with that, let's talk a bit about Kubernetes. Kubernetes is really complex. So it offers resources and abstractions like containers, pods, deployments, replica sets, services, endpoints, secrets, ingress, storage related persistent volume claims, and many more. So along with that, you also have to learn YAMLs, Helm, kubectl, kubeconfigs, etc. So after learning all this, you also have to manage it by yourself. So as a technology stack, it is great, it is superlative, but the learning curve could be steep. So this is where Keynative comes into picture. It is an open source project which gives a simplified view of application management. It is built on top of Kubernetes to leverage all its functionality, but with a lot of abstraction. So it tries to bring in serverless functionality and also running ability to run serverless workloads on Kubernetes. So one can plug in own monitoring, logging, networking components as well. And Keynative is built such that one would be able to cover almost majority of cases in itself. And one just needs to go into the actual nuts and bolts of the Kubernetes for the rest of the complicated cases. But having said that, both Keynative and non-Keynative workloads can be integrated together. This is due to the fact that Keynative itself is running on Kubernetes. So let's look at the Kubernetes, the Keynative primitives. So it is made up of 3 building blocks. One is building, second is serving, and third is eventing. So with build, a developer takes his code and builds a container image out of it. The image could be built using any container technology, for now say Docker. Once the image is created, it is pushed to a container registry, say Docker Hub. All this can be brought on the Kubernetes cluster now. All these steps can be converted to a single manifest deployment. So how this can be done using the eventing component, but prior to that, let's talk about the serving component. So this is the component which is going to serve your application. It uses various technologies under the hood, like service mesh for traffic management, routing, auto scaling, DNS configuration to get the application URLs, certificate manager to make the app secure, and the prerequisite for this is that the images for the application, the application should in itself be running as HTTP server. And also another assumption is that this HTTP server can handle concurrent requests. There are ways to get around this prerequisite of not handling concurrent requests by the HTTP server as well. But yeah, that is just a side note. The third primitive is the eventing component. It implements tooling for managing events, like creating triggers and respond to events. So for example, if there is a new push to the master branch of any source code, we could set up eventing such that it would automatically trigger a build. We are not going to cover eventing in this session deeply, so this may be a topic for another day. Yeah, so let's look at the Keynative serving resources. Let us zoom into those. These are clearly defined separation of concerns in form of the custom resource definitions in Kubernetes. So there are 4 of them. The first one is service, which automatically manages the application's life cycle. Second is configuration, that maintains the desired state of the application, that is the service. Third is the revision, which is the point in snapshot of the code and configuration. And fourth is the route. This resource maps the application endpoints to revisions. Talking a bit about Keynative serving and the functionality as such. So every application is called a service in Keynative world. Each application that is the service, when deployed, gets a revision. So each revision is basically a version of the application. A change to the actual logic or configuration is treated as a new revision. So let us assume that you install an application that is a service. This will create a revision, say revision number 1. Keynative will automatically set up the networking for the application and present an endpoint to the user. Based on the load, the revisions are either scaled up in case of large loads or scaled down if the loads are less. So if no one is hitting the application endpoint, this is also tracked internally by the Keynative infrastructure, and a number of containers or pods running for that application are scaled down to 0 as well. So now let's assume that a user installs a new revision. In that case, the application is automatically migrated to the newer version as well. So this is done automatically by the internal Keynative components. Also, one can split the traffic based on the percentage. So that is if the user, the user can tell Keynative to send say 80% of traffic to the first revision while 20% to the second revision. So this is where one can test a newer version or a newer revision. And once it is tested, the user can start increasing the traffic on the latest revision. Dedicated tags, that's another feature which Keynative provides, where one can create an altogether separate endpoint for the same application. Thus, this tag-based deployment is not going to participate in the load balancing that I mentioned. So this typically is used for testing purposes. So once testing is done, we can slowly start draining old revisions and putting traffic to the latest revisions. One can also put in concurrency limits for pods or for applications. So that is if this limit is reached, a new pod will be spun up for the given application if the load increases. So
one of the interesting things about those two is you can set a min and a max amount of pods too, right? Like, so like say you're getting a lot of traffic and you've got your concurrency limit set up, but you only want to have 100 pods to back that traffic without like spending a ton of money, right? Like you can do something like that too, right? Like where you set min and max.
Yeah, yes, that's true. Min and max can be set.
And if you want high availability to where it doesn't take a moment to spin up a pod to enter a request, you can also set like a minimum, right? Like, so if you set like a min 1, there's always at least one pod running. Yeah, awesome.
Yeah, so that will disable the scale to 0 logic. Okay, so with that, let us go to the Appctl demo. So this is the alpha version of Appctl, and I would be showing it in action to deploy apps in Platform 9 managed backend. So as a first step, we need to download the binary for the Appctl, and this is present or located on the Platform 9 website, where if you hit platform9.com/appctl, there is a link for download for various operating systems. So, okay, so I have already downloaded the Appctl. So this is how the help looks like for Appctl, where there are various commands. The first thing that anyone would have to do is to log in. And this login will be where you will be presented with a device confirmation code. So this is very similar to like verifying the actual device. So if you see this confirmation code, this is similar to what we have seen here. And once you do a confirm, it is going to present you with options for continuing with the Google or GitHub accounts. So let me just quickly continue with Google. I have already logged in with my Google account on this browser, and yes, congratulations, you are all set. So this is going to just be a successful login for Appctl. So let me just quickly list the number of apps that I have right now, and there are none at this moment. So we'll pick a very simple Hello World app that runs an HTTP server, and once you hit the endpoint of the app that the Appctl presents, it is simply going to print Hello World. So let's just do that with a command called deploy. I'm giving this app name as demo hello, and this is the image which is present in the GCR. So let me just quickly deploy it, and it will take less than a minute to get that deployed. Yeah, here it is. So we are presented with a URL which is an endpoint which you can do a curl, and it is working fine. So internally, what happens on the right side of the screen is that I'm logged in into our own environment where I have exported my kubectl, and there is an internal namespace which gets created for my account. And I'm just quickly going to show you the resources that get created. So for example, service, deployment, replica set, configuration, route, revision. So we've talked about all these, right? So this has been internally plumbed and automatically kind of set up, where the developer need not look into it at all. Okay, so let's now, we can also pass environment variables to the app. So, and also change the port if necessary. So let's now try to deploy an app which will take an environment variable as an input. And this is the same image, the hello world image, but right now I'm going to take an environment variable called target. So instead of hello world, it will print hello Appctl. So let's just deploy this with a different name, which is demo hello one, and it is deploying. And we have got an endpoint.
So like as an end user though, I'm just going to see the stuff on the left. I'm not going to see the stuff on the right, right? Like that's what's happening behind the scenes that we're managing.
Yeah, true. So I mean, for we should basically ignore what is happening on the right, but that's just for the demo purpose, since we talked about Keynative.
Awesome, makes sense.
Yeah. So on the left again, let's just curl, and here it is. So we were able to also inject something from the environment variables. So there is also a command called describe. So let's just try to describe the app that we just deployed. So the syntax is just described with the name, and you get all sorts of information. So with this, you get internals of the app, like the status, revision, URL, traffic split, etc. Let's also do a list. So I have two apps deployed, and the list command gives out the name, URL, image from which it was deployed, what's the status of it, and what was the current creation time of it. So with this, as a last step, let us try to deploy a real world app, say Nginx server. So let me just do that. The Nginx server typically runs on port 80. So I'm going to deploy demo Nginx with image from the public PCR registry, and let's just hit it. And we have got a URL. Let's try to hit this on the browser. And there it is. The Nginx server is also running in the backend. So we do a list again. And we have Nginx app also now within a ready state. Last but not the least, let's also try to delete app, say the first app that we created called demo hello, and let's delete that. It is going to prompt for a confirmation, and it got successfully deleted and also removed from the list. Yeah, so with this, we have demonstrated that we are able to deploy apps quickly using Appctl without any burden about the backend infrastructure. And with that, I think I'm done with my demo.
So Anup, I had a question. So you're saying future releases are going to have auto TLS, so HTTPS endpoints, and then the other question is, eventually we're also going to allow private registries.
Yeah, so private registry work is in, so it's already in works, and we'll also have these HTTP endpoints converted into HTTPS. So that is coming soon.
Are we gonna have the option to be able to deploy with, like, is that gonna be an option on the command line to deploy with TLS versus without?
It has not been thought of, but
Okay.
yeah, we can certainly do that.
Yeah, we can. That's a good suggestion. We can take
Okay.
that into account.
So if I want to get started today, I just go to the site, which I'll post again in the chat. I download this, I deploy whatever application I have that I'm testing. So what kind of, here's a question. What kind of use cases are we seeing this for? Like, is this going to be like developers that are trying to get used to using Kubernetes and they just want to deploy an app to see what it looks like? Is this going to be like, hey, we're trying to host like something for you like long-term? Hold on, we have a question too, and question answer. Let me get that fast. Okay, how about if we want to, so this is from Ad here. How about if we want to use specific ports in the app? It looks like there was a port option where we specified port 80. Yeah, I'll let one of you answer that.
If the app is running on any other port than 8080, if you simply pass the port option to the command line, it is going to pick that up and use that port.
So let's say I'm using this and I have questions on it. Where do I get my questions answered? Is that going to be in our Slack?
So I think we do have the Slack channel for PMKFT, and that is where you can simply register.
Yeah, so on the Appctl page that you've linked, Mike, there's links to the Platform Line community page and to the Slack channels. So we're all on there. So many of our engineers are on, and if you have a question, if you try using it and have a problem, or have feedback, or have questions on the roadmap or feature requests, they will get heard, and you will get, you will be responded to. Going back to your previous question, Mike, on who is this for? We think that, look, obviously anyone who's familiar with Kubernetes but wants a simpler and easier way to kind of get access to the richness of Kubernetes but actually run apps, this is for them. But we actually think that we want to, going back to what I shared at the beginning, we want to kind of bring back that delightful simplicity that Docker first had when it first came around, how easy it was to take an application and run it in a Docker container. We want to kind of take advantage, combine that with the power and openness and flexibility that Kubernetes has. So that really is the North Star. So Mike, we want to bring in a lot of developers who might be interested in a lot of the features that Kubernetes has, such as being cloud agnostic, such as being enabling sophisticated auto-scaling up and down, vertically and horizontally, such as doing just-in-time, scale to zero. But they want this to be easy, and they want to be able to focus on building and running their apps without having to deal with a lot of the infrastructure complexity that the raw kubectl API, kubectl command line entails. So that's really the goal, is to open up the community of people who are using Kubernetes by making it more accessible and easier to use for a broader range of developers.
Awesome. That sounds great. Well, I'll say thank you so much for everybody for coming. I think that's pretty much the end of our presentation. If we have any other questions, we can take those real quick. But if not, we'll go ahead and end the session, and this will get posted to YouTube in the next couple of hours in case you want to rewatch the beginning or watch the whole thing again on demand. And like I said, if you have any questions or anything, join our community. There's some information on the Appctl page where you can join the community or ask in our forums and stuff like that if you run into problems. But thank you, everyone. Thank you so much. I think we can end there unless you have anything else to say, Sirish or Nikhil.
Mike, thank you for having us. It was a pleasure. Look forward to getting back on with an update. Once we maybe add some of these features, we'd love to come back on and show some of the new capabilities.
Great. All right. Thank you so much, everyone. Thank you for coming.
Thanks,
we'll see
Mike.
you again in a couple of weeks.
Thank you all.
Thanks all. Bye.
Thanks. Bye.